Welcome students. We are back with another lesson. In this lesson we'll discuss photoelectric effect. Now before we discuss your photoelectric effect, let us get an idea about your free electrons. Okay, so your conductor, the conductor consists of loosely bound electrons. Can you see the outermost electrons? They are constantly jumping from one atom to the another atom. So such kind of electrons, they are your loosely bound electrons. So this loosely bound electrons, we call it also as your free electrons. This free electrons move throughout your conductor. As you can see in this picture, the electrons are jumping from one atom to the other. Now the electrons are free within the conductor. They are confined inside the conductor. That means these electrons cannot jump out of the conductor. They cannot move beyond the boundary of this conductor. Now this is not always the case. I can eject this electron from the conductor. Now there are various methods by which I can remove these electrons from the metal surface. Now the phenomenon by which the electrons are emitted from this metal is known as your electron emission. Now there are various methods of your electron emission. The first method is by heating the conductor. By heating the conductor, what happens? This conductor gains sufficient energy, and if this conductor gains sufficient energy, that means this loosely bound electrons get sufficient energy to be emitted out of this conductor. Such type of emissions are known as your thermionic emission, where you supply temperature. Therm is the Greek letter word for temperature. Thermodynamics, just like you have seen in thermodynamics. So you supply temperature and you convert it into ions. So thermionic emission. Fine. The next type of emission is your field emission, where you apply a strong, whether be electric or your magnetic field in this direction. What happens? The electrons in the conductor, they get attracted towards the positive terminal, to the positive side. So this way also you can eject the electrons out of this conductor. So such kind of emission are known as your field emission. Now in next type of emission, you shine or you radiate a electromagnetic radiation like your sunlight, on this metal surface. So it transfers its energy to the conductor, to the outermost electron. And what happens? The electrons are emitted. Fine. Such type of emissions are known as your photoelectric effect. I'll explain you what is this photoelectric effect. For now you can understand like this photo. Photo means color. That means your colored light. Like your sunlight. When it falls on your metal surface, electrons are emitted. Such kind of process of electron emission is known as your photoelectric effect. Now we will focus more on your photoelectric effect. Fine. Out of all the emission of electrons, out of all this phenomenon of this emission of electrons, we will study about the photoelectric effect. Fine. And finally, this is the fourth kind of electron emission, where a fast moving electrons, this fast moving electron strikes a metal surface. When this fast moving electron strikes a metal surface, what happens? It knocks an electron out of this metal surface. Fine. So such kind of emission are known as your secondary emission. Now look into this picture. Here the energy required in all of this process, in all of those four electron emission phenomenon, the energy required to eject the electron out of this metal surface is known as your work function. So the work function is the minimum amount of energy required by an electron to just escape from the metal surface is called work function of the metal, and it is denoted by W naught or phi naught, and it is measured in electron volts. So what is your electron volts? So 1 electron volt is the kinetic energy gained by an electron when it is accelerated through a potential difference of 1 volts. So imagine you have a conductor. Now in this conductor I'll apply a potential. Let us say I've applied a potential of 1 volts. So what happens? The electron inside the conductor will start to move towards your positive charge. Right? So while moving, the kinetic energy gained by this electron when it is under the influence of 1 volts. This kinetic energy is known as electron volt. This is the kinetic energy which is gained by this electron under the influence of 1 volt when this electron is moving in the potential of 1 volt. Therefore, this energy unit is known as your electron volt. Right? Fine. So now let's discuss your photoelectric effect. So this is a apparatus of photoelectric effect. Now let us look at the apparatus. In this apparatus, you have a light source which produces the light radiation. After this light source, we have a metal surface. This metal surface acts as your cathode. Now after this, we have a anode. This anode acts as your detector. Now your cathode and your anode, your metal surface and your detector, they are in turn connected with your battery and ammeter. Now my battery has a negative and a positive terminal. Now your cathode, your metal surface and your anode, your detector, are placed in an evacuated glass tube. Fine. So this is the apparatus. Now let's see how this photoelectric emission takes place. So in this case, a light radiation falls on your metal surface. So you are supplying some energy. Now from this metal surface, electrons are emitted which are detected by your detector. This detector in turn will flow through the battery and it will flow through the emitter. Now these electrons are detected by your emitter. And note, the battery is there just to provide the direction of the current, in which direction the current should flow. Fine. So let's define your photoelectric effect. The phenomenon of emission of electrons from a metal surface when electromagnetic radiations of sufficiently high frequencies are incident on it is called as photoelectric effect. And the photo or the light generated electrons in this photoelectric effect, the emitted electrons which were produced, these electrons are known as your photoelectrons. Fine. So that's it for today's class. Thank you. And if you have any confusion, please don't hesitate to ask. I will re-explain it to you again. And the link for this animated video for the photoelectric emission I will give you in the PDF. So again, thank you.